All right, we're going to continue our discussion here. And so our next question we're going to look at is a projectile fired into the air suddenly explodes into several fragments. Okay, and there's a couple questions about it, but I just want to think about what's going on. So if we had a projectile, it would have taken this trajectory, okay, based on the force of gravity pulling it and causing it, giving it a net downward acceleration throughout its flight. Okay, and what happens to this particle is at this point, partway through the flight, it explodes. So something inside of it causes pieces to fly apart. Okay, and so before we talk about answering the questions here, let's think about what Newton's laws say. Okay, when we have a net force on something, it causes acceleration to happen. And when we talk about that net force and we draw the free body diagrams on an object, the forces we draw are always the forces external to the object. So for this, flying through the air, the only force acting on it is a downward gravitational force throughout the entire flight. That's the only external force if we're focusing on this system of particles and the forces that are coming from outside of it. That doesn't change from here before the explosion to here after. Okay, we have that same single external force, which means it's going to cause it basically to have the same motion that it would have beforehand. Except it doesn't because it exploded. It's in a whole bunch of pieces. So those pieces are going to kind of fly off like this and like this and like this, maybe something way over here. Okay, and they're just going to land everywhere. Well, if we were to track the center of mass of those pieces, they'll maintain the same path of flight. Okay, and when they land, the center of mass of all those pieces are going to be right here where the particle would have landed. Now the pieces are going to be scattered everywhere, but the average location of their mass is going to be right here where they were supposed to land in the first place. Okay, and this goes back to Newton's laws because there was just this one external force acting on it. Okay, without any other forces acting, nothing external to it, nothing caused that to change. Now, if we look at when it exploded, what's happening there is there's an internal force causing the shape of the object to change. Since that's just an internal force, it doesn't actually affect it doesn't actually change what forces are acting external to the center of mass. So when we come to these questions as to what can be said about the motion of the center of mass of the system, well, it's going to maintain that same path that it would have been taking the whole time. Okay, it wouldn't even notice. The center mass doesn't even notice that the projectile exploded on its way down. Okay, then it said, if the projectile did not explode, it would land a distance r from its launch point. Suppose the projectile explodes and split into two pieces of equal mass. One piece lands at a distance 2r from the launch point. Where's the other piece land? Well, if it's going to land at this distance 2r, okay, and this is 1/2 of the mass, okay, where would the other piece of mass have to be in order for that center of mass still to be in this same location we started? Well, it's going to have to be right here where it was launched from. Okay, and the average location of these two pieces is that same piece. So somehow this piece is going to fly all the way back to where it started.